How you doing, guys? Mr. Lombardo. I'm taking over. Well, not quite, but I'm filling in for Mr. Bronson until your new teacher comes in. So I know this is definitely going to be a huge adjustment for you guys, but just kind of bear with it. All right, it won't be the worst. It won't be the end of the world. Um, you know, I'm going to do my best to work with you guys and just be patient. It's new. And, you guys haven't done anything like that or experienced this probably. I'm on the same level. All right, so I have my own classes that I am teaching, but I'm going to kind of fill in and post some different assignments and things for you guys, and I'll be available for you guys on the Google Meets after school for the virtual hour from 12:30 to 1:30. So if you do have questions, yeah, you can stop by and definitely ask me during that. So I'm just going to run through a little bit of the PowerPoint that I had posted today on like circular motion. Don't worry about this little chapter piece. That was from kind of something different. Going forward, we may wind up using the book, the online version of your book, as you can use it as a resource. I may not always pull assignments from there, but it'll be available for you to kind of go on and read and look through different pieces of information. So just kind of rolling through some of this stuff, you need to understand the difference between rotation and revolutions. Giving you guys the definitions here, pretty simple, pretty straightforward. These are the kind of gists. These are the terms of the variables and stuff that you're going to wind up needing to solve for, that I'm going to wind up making you guys solve for. So tangential speed or tangential velocity, frequency and period, centripetal force, centripetal acceleration. So tangential speed and tangential velocity, they're basically referring to the same thing, so you don't need to freak out over that. Angular speed, linear speed, linear tangential speed sometimes can be, back and forth. It may be talked about as one in some resource and talked about as tangential in a different resource. So it depends on what you're looking at. So frequency that we're going to need to know is frequency is going to be the number of revolutions that an object completes per period of time. We're usually going to do the number of revolutions per second, which we're going to give into the unit of hertz, capital H, lowercase z. Revolutions per minute, if we get that in a problem, probably want to get out of that, and just so you divide it by 60 to put it into hertz. Period. This is the time an object's going to take to complete one lap or one complete circle, one complete revolution. That's going to be in a unit of time. Usually it's going to be in seconds, especially if frequency is in hertz. So how are these two things related? They're the inverses of one another. So if you're given this triangle, you can, if you guys are hopefully familiar with it. If not, I'm just going to kind of briefly run through it. Whatever you're given or whatever you're looking for, let's say whatever you're looking for, you're looking for frequency and you have period. They want to know what the frequency of something is. So f equals, lowercase f equals whatever's left. So if you covered up f, it's going to be 1 divided by t. And that's where we got the equation over here. Period is going to be 1 over the frequency. So they're inverses of one another. If you have one, you can find the other. Angular speed, amount of rotations per time interval, Greek symbol omega. Angular speed, we're not really going to be solving too much for, but I just want you to know that it's going to be constant at any point on an object's circular path. Okay, units will be revolutions per second, rotations per second, revolutions per minute. Your tangential or linear velocity. So at any given point, if there's a tangent vector drawn on the circle, it would be like a straight line speed at that point in time, at that instant. Now, to solve for that, there's two equations that I'm going to ask you guys to use. Velocity is going to be 2 pi r over the period, or 2 pi r times f. Either one of those will give you the exact, the exact thing that you're asked to solve for. Units are going to be in meters per second. So your tangential speed is going to be greater the farther away from the circle you go. The angular speed is constant everywhere. So if you're thinking about horses on a carousel. And this black line, black bar here is to represent, all right, all 4 horses, all right, all on the same line. As this goes around, this bar is not going to like bend or change or anything like that. It's going to stay straight like this. So all the horses are going to make the same amount of rotations. They're going to complete the same amount of laps, all right, same amount of spins, however you want to say it. But if you can look, the farther away you go, the greater the distance you're going to wind up traveling. So you're going to have a greater tangential speed. The angular speed or rotational speed, that will be equal, all right, at any single point. So if this was like horse A, B, C, D, they would have the whole angular speed, rotational speed to be the same, but the farther away you go, the greater the tangential speed will be. Okay, this kind of asks you to go around and solve for period, frequency, tangential speed. Given the radius, given the fact that you complete 1 lap in 3 seconds, that's why the period is 3, because you're completing 1 whole lap or 1 whole revolution. So the frequency is the inverse of that, 1 divided by t, just 0.3 repeating, and then your tangential velocity or tangential speed, you have the radius here, so 2 pi r over t or 2 pi r times f. Either way, it's going to wind up giving you the same answer. Again, going through all this kind of stuff here, RPMs, if they wanted this, they want it in hertz, so get this divided out by 60 to give it into your frequency in hertz, 1 over that to get your period in seconds, and then use your tangential speed or linear speed equation. Okay, go through all this. How does the velocity vary with the radius? For tangential or linear speed, the farther from the center you go, the greater it's going to be. Very, very simple. How does the frequency depend on the radius? It doesn't matter. How far you go away from the center, you're still going to complete the same amount of rotations or revolutions. Centripetal acceleration. The word centripetal means center seeking. So you're going to see it sometimes as A sub c. It can just sometimes be listed as A. You're going to take the velocity of the object squared divided by its radius. Now the velocity, since it's constantly changing while it's in a circular path, means that the object has to be undergoing an acceleration. The acceleration for this object is always going to be pointed towards the center. There's a couple of little videos on here that you can kind of go through and look and at your own pace or your own time. Okay, they want you to figure out the concepts here of velocity and acceleration. So what vector would represent the velocity when the object is located at point B? So if we're here and the object is going clockwise, right? So 12, 1, 2, 3, 4, 5, 6, 7. So it's going to be tangent at any given point. So if it's rotating clockwise at point B, it should be straight down, letter D. And the acceleration vector is always going to be pointed inward. So however the arrows are going to be is going to go along with whatever points are at. Velocity is going to be tangent, acceleration pointing inward. A couple of sample problems here that give you the how to solve for those. Here's a couple little example problems for you guys. Centripetal force, F sub c is equal to mv squared over r. If you replaced if you replace velocity with our equation for velocity is 2 pi r over t. V squared, you can see is sometimes on different resources is like mv squared. No, well, m times 4 pi over t. We're not going to really deal with that, but you can wind up seeing that as an example. All the equations that I'm going to have you guys use, I'm going to wind up just giving you, so you don't need to freak out. So in this one, they're now talking about the force vector. So force is located inward, so is acceleration. Velocity is still going to be tangent to the circular path. How does centripetal force change if certain things are doubled? Well, if mass is doubled, if we look at the equation, the force is going to want it being doubled, directly proportional. If you increase the velocity by a factor of 2, it's squared, so the centripetal force will quadruple. And how it changes with r, it's going to wind up being the inverse of it. So you divide by a smaller number, you're going to wind up having a larger force. So you can kind of go through and figure out what those are. All right, so units for these guys that we're going to use: newtons, kilograms for the mass, velocity, meters per second, acceleration, meters per second squared. The rest of that we don't really need. So I just wanted to kind of go through your assignment for today. Going through, knowing what the variables and everything are now, you can kind of hopefully deal with this a little bit better. So just for a couple little examples here, what is centripetal force? So F sub c is your equation. Let me zoom in here. F sub c, centripetal force, is our equation, and that is equal to mv squared over r. All right, we need these three variables. We're given a mass of 3.4 kilograms. Got a rope radius here. The length of the rope is 1.2 meters. Someone asks that, well, don't we have to cut that in half? Well, if you hold the rope by like this point and it's 1.2 meters long and it's being swung around in a circle, that would wind up being the radius. So the radius is that 1.2 meters. And it is giving us a tangential speed, tangential velocity, v, of 3.5 meters per second. So plugging them into the correct spots on the equation, mass was 3.4. You're squaring the velocity only, so 3.5. That's an awful 3. Jeez Louise. 3.5 squared over the radius of 1.2. And you should come out with a roughly, if you round to 2 decimals, right around like 34.71 newtons. And this one, diameter they give you, so you have to make sure that you use the radius of 2.5. Got to make sure that dude is cut in half. You're looking for centripetal acceleration. So the radius is 2.5 meters. The tangential speed, tangential velocity, 1.628 meters per second. They want centripetal acceleration. That's your question mark. Find it up here. AC is v squared over r. You're just going to kind of plug your numbers in here and to solve for it. So 0.628 squared over, it's come out to be about 0.16 meters per second squared. Because it's an acceleration, you're going to have the meters per second squared. All right, finding centripetal force. In these ones, you're finding centripetal force. All right, kg is mass. All right, the meter length of the string is r. This is v, so you have mv squared divided by r for these problems. The yo-yo, you're given a velocity, you're given a radius, centripetal acceleration, pretty straightforward. Centripetal acceleration again for number 6, so that one shouldn't be too bad. Okay, so dog sits 1.5 meters from the center. of the merry-go-round with a certain velocity, find the acceleration. Okay, very, very straightforward. Again, number 8, though, calculate the tangential speed of the 3 horses on a merry-go-round that all complete 1 revolution around the track in 9 seconds. Okay, so the fact that they complete 1 revolution in 9 seconds means that the period of these things is going to just be 9 seconds. Now, that's all 3 horses on the same, like on the same rung or same pole, like I looked at in the notes, and they all are going to move at the same rotational speed. So they're all going to make the same amount of turns, laps, revolutions. So in each one of these A, B, C, your period is going to wind up being 9 seconds. So to calculate the tangential velocity, you're going to wind up needing this equation. It's on the front side of your worksheet here, which would be 2 pi r over t. That is an awful pi. I'm just leaving it. I'm leaving it. It's awful. No good. But, so yeah, you're going to basically just going to go through and solve. So you're given r, you have t. That's really it, because it's 2 and pi. So 2 pi times 3.5 over 9, and you can round it about just 2 decimals. All right, it should come out to be about, roughly in this case, 2.44. Unit will just be meters per second, not meters per second squared. It's not acceleration. Okay, so you do that for those problems. The next one, they would like you to solve for the velocity. And what do they give you? They give you an acceleration of 3.2 meters per second squared. They give you the length of the rope as our radius of 4.1 meters. They want the velocity. Okay, so those are our variables. We don't have a straight velocity equation, right? We don't have 2 pi r over t, but there's another one on the front side that is giving us that the velocity would be equivalent to a times r. A sub c or a, doesn't matter however it's written, times r, and then square root. Units will be the same. In the next one, a carnival ride has a 2-meter radius, rotates once in 90 seconds. So A, find the speed of the rider. So A, you're looking for V. Two pi r over t. What are we given? We're given r of 2, and we're given t of 0.90. So you're going to substitute in t and r. You're going to calculate for velocity. Once you have found that answer, then you can find the acceleration. So solve for the velocity first. Once you get the answer, that will be here to complete your problem. In number 11, cement mixer has a radius of 2.5, frequency of 0.0, 200 hertz. What is the centripetal acceleration acting on an ant on the inside wall? Okay, I kind of listed what I want you guys to solve for each first individually. If you solve for the period, all right, capital T is equal to 1 over the frequency. That is an F. So once you solve for T, then you can solve for V. And once you solve for V, then you can solve for A. The last one, you got a mass, you have a radius, and this thing completes 27 revolutions in 1 minute. So first, frequency. All right, this would give us RPM, revolutions per minute. We got to get it out of that. So the frequency would be 27 per 60. We're going to get 0.45 hertz as your frequency. Now for T, once you get T, it's 1 over F. And then kind of how we did the other guys up top. Once you have T, you can solve for the velocity because you have R already. So 2 pi R over your T, and then the centripetal force. So once you solve for V, you can get this guy here, all right, mv squared over R. You can go through and then complete these problems. And then just the last little bit, definitions, can match them up with these guys that you need. Rotational speed, what I'm essentially looking for is a spinning mobile here. Think about it the same way as the horses on a carousel or merry-go-round, however you say it. This thing is not going to bend. It's a straight bar, so as it spins, everyone is going to wind up completing the same amount of rotations for a period of time. So the rotational speed would just say, you would all say that they're the same. You could say the rotational speed is the same, or A equals B, which equals C, which equals D. But the tangential speed or linear speed, tangential velocity, that depends on, all right, your distance from the center. The farther away you are, the greater that speed will be. All right. So I hope, guys, that helps with your assignment.